derivatives for semester 2 with 4.9. It's the end of the applications of derivatives. You kind of squeeze it in there, but the connections among mathematics are amazing. So you're going to see a connection between derivatives and antiderivatives. So what you're looking at is if you're given a function such as sin x. And I asked you, what is the derivative of sin x? No? Sine is cosine, right? Okay, that's all on there. You know that. You have a bunch of memory derivatives you could spit out right now, probably. Here's the kicker. An antiderivative, you have a derivative, you antiderive, you end up back at the original as an antiderivative. So that's going to be key. It's an antiderivative, not the. Okay. So you've got a whole host of these at your disposal. F of x is cosine x. The derivative of that is negative sine x. So if you have negative sine x, the antiderivative of negative sine would be cosine. Okay. Additionally, let's talk about what if g is negative cosine x? And then you know that g prime of x is going to be sine x. So an antiderivative of sine x is negative cosine. All right, you'll see this is the more common question. All right. So that's just kind of an idea of the relationship between the two, derivatives and antiderivatives. Okay, but do keep in mind, I'm going to address the word and we're going to make it a the, because this is only one option. Okay, the power rule should be easy enough to grasp. Okay, so if you have some function h is x squared, okay, the derivative is 2x, right? An antiderivative would be x squared. Okay, so what are you doing with the power rule? Here, you are, let's generalize this. Right. Here, h prime of x is, you bring it down, bring the end down, and subtract 1 from the exponent. Right? Good. For an antiderivative, how are you going to generalize to get back to this? Okay. Well, you could say that we add 1 to the exponent, right? That'll get us back. And so it would be x to the n minus 1 plus 1. So you've added 1 to the exponent. Now how do you get rid of n? Well, divide by this. Okay, so you get, this is nx to the n over n. If you do the math there, so you get x to the n, which you see as our original. Okay. Now again, that's an antiderivative. Okay, so you're just playing the game that you already know. Okay. Here's what we are kind of shielding you from, and I'm going to show it to you. What if I give you a function, k, that has a constant? Okay, what's the derivative? 3x squared. And that derivative of 2 is 0, correct? Okay. Well, up until now, you antiderive you would get x cubed. But you could not generate the 2. Right. So if you have a function that's a derivative, you antiderive, you do not know what kind of constant is there. Okay? Because we don't know this. This is unknown at this time. Right? So what we would actually write is the general antiderivative you notice the word the, okay, instead of an, would be k of x equals x cubed plus c. C is a constant. What would we call that? An unknown number. Okay? So when we antiderive, we have to put a plus c on it every time. For now. We'll get rid of that at some point here pretty soon, but for now, just keep in mind the general antiderivative has to have a plus c. Okay? The other so let's just talk about a couple. So what if I give you f of x equals secant squared x? Okay. The antiderivative is oftentimes noted as a big f of x. Okay, because this is not in derivative notation here. Right, so we have to find some way to note it. So the antiderivative would be f of x is tan x plus c. Okay. Remember that plus c because we don't know if this, we don't have the original function, the derivative. Okay, we don't have that original function for which this is generated, so we don't know if there's a constant or not. Okay. So here's another way to write this. It's called an indefinite, this is called integral notation. And this is usually how you will see it. Okay, so we would write, let's say, given a function, let's just say we'd be given f of x. The integral of f of x dx. So here's your function and here's your notation. This means antiderive. Okay, equals big F plus a constant. So you see that big F here. It's the same thing we did here, just a different notation. Okay, this is called an indefinite integral. Right? When we get to definite integrals, we'll get rid of that plus c. But for now, we don't have that ability to get rid of the c because this is an indefinite integral. Okay. So again, looking at a problem, we could say calculate the integral of cosecant squared of x. Okay. That is going to be a negative cotangent. Or am I wait? Hold on a second. Yeah, I'm right. Trust my memory. plus a constant, okay? So, and again, this is the way you'll want to be writing it from now on, okay? Right, so just know your derivative. You know, the derivative of cotangent is negative cosecant squared, so you just have to play with the negative there a little bit, right? Because the derivative. So d over dx of negative cotangent x would be cosecant squared x, right? We could put a plus c there if we want. Okay, so that relationship holds. All right, so let's write this out in general. Okay, this is key. A function, don't forget the fun, f of x, big F, is an antiderivative of f of x on AD if f prime of x equals f of x for all x in the interval. Okay, so let's just say what we've been doing. You have an antiderivative. If you derive it, you get the original function. Okay. Another way to write this would be to integrate f prime of x okay, so what do the integral and the derivative do? They're inverses, so what you end up with is f of x plus c is the integral little f of x. Okay, that's another way to think about it. This is probably, like on the AP exam, you'll see this, right? They'll give you that information, but I find it easier myself to actually rewrite it on my paper like that. Okay, so anytime you see something of this nature, it is best, in my opinion, to rewrite it as such. All right? So that's just the formal definition there. Okay, and you'll see that as an indefinite integral as well. Okay. So look on Google Classroom. There are a few problems for you to do. Make sure you took notes on this because you'll turn them in, or I'm going to check them. I'll give you a few problems to do, and we'll continue to look at antiderivatives the next 3 days, Thursday, Friday, and Tuesday of next week. All right. Toodles.